Today's all about setting up for completing the square. Next class, the next block class we have, we will really get into completing the square, but today's all about setting it up so that we have an understanding of why completing the square works and what the square is. Okay? So when we are talking about completing the square that we're talking about is a binomial squared. Okay, and that's the Batman meme up there, and we're going to get into it, and I'm going to talk about it here in a little bit. Right? When I have a binomial squared, we're talking about two different potential situations. Either one of these two. Either you have a sum of two terms, all squared, that binomial squared, or we have a difference of two terms, binomial squared. Okay? Those are my two different scenarios. Now, why it's the Batman meme is because lots of times, and you guys will do this too, you will write that this equals a squared plus b squared, or you'll say that this equals a squared minus b squared. That is not true. That's why Batman is slapping Robin. Okay? That's not what it equals, because in reality, what this is either a plus b times a plus b, or a minus b times a minus b. So I want you to FOIL those out and see what you get. So do that now. As you notice, when you FOIL this out, you have these middle terms. And in fact, those middle terms are the same as each other. Okay? And so when I have this middle term 2ab, or minus 2ab, depending on whether it's plus or minus. Okay? So this is where the mistake is made. If you immediately say this is a squared plus b squared, you're leaving out this middle term. If you say that this is a squared minus b squared, you're leaving out the middle term. And the key thing is to not leave that middle term out. Okay? Now, this form for a binomial squared will always work like that. Okay? It's the first term squared, the last term squared. The middle term is the numbers multiplied by each other times 2. Okay, the middle multiplied by each other times 2. It will always work like that in that pattern. Okay, and so to put that, here's what it is. The square root of the first term times the square root of the last term. So if I start where I end, notice this. The square root of a squared is a. The square root of b squared is b. Multiply them together times 2. That's going to be the middle term. So that's another pattern you're going to need to recognize. Square root of a squared times the square root of b squared times 2 gives me the middle term. And that's what this all says. Look at an example. Is this a binomial squared? Okay. Now, here's how we figure this out. Okay. So just like those last couple lines that you wrote in your notes, okay, I take the square root of x squared. What is that? X. Square root of x squared is x. Square root of 36. Okay, multiply them together times 2. So that's what we're doing. We're taking the square root of x squared, the square root of 36, we're multiplying it times 2. If these all multiply together to give me the middle term, then it's a binomial squared. Do they? Is x times 6 times 2 12? Oh. No. So yes, so the 12 is negative. It's not positive 12. So when I write this as a binomial squared, the middle will just be minus. So here's what it's going to look like. Okay? Does it equal the middle term? Yes. So here's what it looks like. So when I rewrite it as a binomial squared, all I do is I take that square root term and put it on either end, and then that minus sign drops in. Okay? If you were to FOIL this out, x minus 6 times x minus 6, you would get this. The point of this is we can do this, if we know the pattern, we can do it in a much shorter, quicker way, if you recognize the pattern. And this is factoring. Okay, that's a quick way to factor that down. Yeah?
Isn't that like what we just did, but we're just writing it differently?
Correct. We are writing it differently. And there's two reasons why we're writing it differently. We can solve quadratics using square root property, which we're going to do. And we also need to be able to get things in this form because, as I talked about when we started looking at parabolas, there's another form for parabolas. There's standard form, which we've looked at. There is vertex form. And we need to be able to do this to get it to vertex form. Okay? Here's another example. Okay? Is this a binomial squared? So go through the process again. Take the square root of the n terms, multiply it by 2, and see if it equals the middle term. Right? What is the square root of this first term? 2x. What is the square root of the last term? Okay? And then I have to take those together times 2. So 2x times 5 times 2. Does that equal 18x?
No.
It does not. Okay, so what does this mean? It's not a binomial squared, correct. This is not a binomial squared. Okay? So I can't rewrite it in this kind of form. It may be factorable, I don't know if it is or not. Okay? But it can't be factored in this way. Questions? Yes.
So does that
See, eventually what this is all leading up to is you're going to come across things like this where it's not a binomial square, but we're going to manipulate the expression to turn it into one. And that's what we're doing on Thursday. Okay? And that's what completing the square really is. Completing the square is turning an expression that is not a binomial square into a binomial square. And that's what this is all leading to, but we're just doing this part first. Okay? Alright. Now, one of the things that we can do, and I purposely use the same expression, x squared minus 12x plus 36, is we can solve using the square root property. Now, in the past, when we had a quadratic, we always wanted to make one side 0. But for completing the square, we're not going to do that. We're gonna actually try to use our binomial square and solve it that way. We already turned this into a binomial square. What was that expression? Yeah, Nate.
X minus 6 squared.
X minus 6 squared. We say, and what we typically say is the quantity, when we're trying to say about the parentheses, when we say the quantity x minus 6, then we're saying x minus 6 is all in parentheses. So since 25 is a perfect square, solve using the square root property means I'm just going to take the square root of both sides. And again, I'm undoing this squaring. 25 wouldn't even have to be a perfect square, to be honest, but if it says solve using the square root property, that means eventually we're going to take the square root of both sides. And when we do that, you have to take the plus or minus of the other side. And that was in that second video that I emailed out to you for some of those questions that you had to do. Okay? So on this left side, the square root and the squaring cancel, so I'm just left with x minus 6. What is the square root of 25? 5. So here's what this gives me. So I have x minus 6 equals plus or minus 5. And I need to solve for x. So what do I need to do? Yeah. Add 6 to both sides. Here's what this means. Let's understand what that plus or minus actually means. It's just a shorthand way of writing positive 5 and negative 5. So in reality, what I have here are two expressions that look like this. 6 plus 5, that's going to be one of my answers. 6 minus 5, that's going to be my other answer. Okay, so what are my answers? Yeah. 11 and 1. That's how we would solve using the square root property. When it asks you to solve using the square root property, you're eventually going to take the square root of both sides. You'll have a binomial squared on one side and a number on the other side. It may or may not be a perfect square, okay? But you will have a binomial squared over there. And whenever you take the square root of both sides, the reason that we do plus or minus is because there are numbers that can, when we square them, you can square the positive and get one number. You can square the negative and get the same number. That's why there's always those two answers. Okay. Anytime you have an x squared, you should end up with two answers. Now it's possible that you have what's called a double root. We've talked about that. It's possible you can have imaginary solutions. We will talk about that. Okay, we haven't really gotten there yet. The other part of your homework that you're going to have to do. So this is one part of it. Okay, go back here real quick. So instead of having a problem where it's already done for you, you're going to have to go, okay, is this a binomial squared? Square root times 2, and then you're going to have to write it out like that. We already did it for that particular problem, But for your homework, you're going to have to end up doing that for several problems. But you're going to have time to work on it during class today and get a start at it. And the other thing that you're going to do is you're going to have questions like this, okay? You're gonna have to figure out what C is in order to make this a perfect square or a binomial square. Okay? The book will sometimes refer to it as a perfect square instead of binomial square. Same thing. Okay? So now we're gonna kind of work it backwards. We gotta figure out what value does C need to be in order to make this thing a perfect square. And so we're gonna work it all kind of backwards. Alright? So here's how that goes. So the first thing I'm going to do is I'm going to find half of 16, this middle term. Because that's undoing the times 2 that we've been doing, right? So what's half of 16? 8. So I'm working with 8. And then I'm going to square that number. So what's that? 64. Now in this case, you're going to add that to the x squared plus 16x, meaning we're going to replace C with 64. Okay? And so that's what my C value is. So by dividing that middle term by 2 and then squaring it, I'm coming up with that last term. Now, this is a unique situation, and this is again another step leading us to completing the square. Notice that the leading coefficient is a 1 on this x squared. In order to do these types of problems, in order to do completing the square, this needs to be a 1. And sometimes it won't be, and we're going to have to make it that way. But the first few problems that you're going to work on today will be set up like that for you. Okay? So that's the first part. We found C. C has to be 64. Then write it as a perfect square. So now I need to take this and put it into that binomial squared notation. Right? So the front term is the square root. The last term is the square root. Since it's plus, it's plus. So we would write it like that. Okay? Again, square root of that, square root of that. And it's always going to be that number that you came up with here. This number, when you divide by 2, and this number will be the same. Okay? Because you're squaring it to get it here. So if you square root this, you get the number that you just squared. Right? It's just undoing that again. So that's the other part of your homework that you're going to be working on today. Alright, that's just the lead-in. On Thursday, we will work on actually completing the square inside an equation. Okay? And that's enough about that. Alright? Questions?